Hello everybody, welcome to lab number 6 in our Python data cartography programming class that we're doing this semester. And this week we're going to be looking at grouping, merging, and no charts. So we're going to be looking at grouping and merging data. We're going to save the charts for another time. I'll just fix that in real time. All right. And the idea with grouping data is that when we have data at a certain level of specificity, right, granularity, we can kind of sum it up by characteristics in the data or by values in a column, and then we can do aggregate functions like a sum of all of the data in that category, right? So this week we're going to be looking at our city data, the U.S. demographics in cities that are larger than 100,000 people for the United States based on the 2022 ACS. And here I just loaded our libraries as usual. We're not adding any new libraries this week. We might not be using all of these, but I think we are mostly. And then we're going to load that data. It's already been cleaned and ready for us. This is the U.S. city demographics, right? So here's just a sample of 5 rows from there. We have the city, we have the state, and then we have total population, median income, and then these are the counts for the ethnic racial groups, and the counts for the people who are living with poverty in that one location, right? So I read this, I see Charleston, South Carolina. There are 149,960 people living there. The median income is 83,891, and then there are, 114 people identified as Native American, American Indian living in that area. And with poverty, this is not a poverty rate or percentage. This is just the number of people, 18,153 people according to the 2022 ACS who are experiencing poverty, right? Living below the poverty level. So to get a rate, like I'd have to divide it by the total population. Same for any of these. Like these aren't the percentages. It's just the number of people that responded in the survey, right? Or the estimate. When we group data, let's say we want to group it by the state. So we can group it by this column state. And then we could do something like sum up all of the people who live, sum up this column total population, and that will give us all of the people in the state who live in a city of 100,000 people or more. So let me just pop a code block in here, and we'll do that, right? So we have cities, and we're going to run the function called groupby, and we tell it which column or columns we want to group by. So we're going to group by state, right? And I can run that and you'll see what we get. We get a group by data frame, right? So it doesn't, there's nothing to really show yet, but it's now grouped the data by the state column. So there are 2 steps. The next we want to run an aggregate function, and we can do sum, right? So that's going to sum up, it's going to add all the values. So here we have our grouped data, and there's a little bit of a problem in that this doesn't make sense in a sum, so we could drop that. Let's say that to make this easier to read, let's just do state and total pop, okay? And get that sum. So now we have the total urban population of Alaska is 290,000, Alabama 907,000, and so on. And these are sorted in alphabetical order because that's how our data was initially sorted, right? We want to see New York. We see we've got 9 million, almost 9.5 million people living in urban areas, right? All right, so this is a group by. We're grouping we always need to we need to have at least have the columns that are included in the group, and then whichever columns we want to run the aggregate function. And here our aggregate is sum. So they need to be in our selection list of columns. But we often want to drop some columns out because it doesn't make sense to run a sum or like an average mean on a column of strings, right? So we wouldn't include that in the output data. And then you see state is treated as an index. You can see there are two different levels. So it's not grouped, but we will get exactly one value for each of the values in the state column. All right, so while there might have been, several cities in Alabama, we just get one row for Alabama because we grouped them all together into the Alabama column. All right, I'm going to leave this here, and we'll just take a look at a more full example. So here I create a variable called cols, and we're not going to look at every single column. We're just going to get the state, which we're going to group by, and then the total population, and then the population in the four largest ethnic racial categories: Asian, Black, Latino, white, right? So we're going to save that result into a new data frame. So once we call sum, we get a regular data frame back. And do you remember how up here we had, let me put a head on that, head 5. Right, so here we've got this 2 level of columns. What we're going to do is we're going to flatten the index so that they look like regular columns. And then we can sort it. We're going to sort it on total population descending. And we show that data. So here's just to remember a little markdown. Level 2 title, total population in large cities by state. And we get them descending by population. So California has the most, then Texas and New York, then Florida and Arizona, right? So these are the biggest states, and they're also have big cities, so they're more urbanized than other states, right? So sum is just one of several aggregate functions. We can also do mean. So we do the same thing here, but we're just going to take the state and the median income. We group by state and we call mean on it, and here we get the average median income of cities, large cities in California, is $96,000. And if we wanted to see the bottom of that group, we could switch this to tail, right? So in Puerto Rico, the average median income is only $27,000. In Mississippi, it's $42,000. Okay. Now, sometimes and often, we will want to switch up the aggregate functions where we want like a sum on some columns and a mean on other columns. So if we wanted total population and median income, we would actually want a different aggregate function on them. And this next code block shows us how to do that, right? So it doesn't make, we could do the mean city size would be fine, a reasonable thing to do. But the total median income doesn't really make sense in a lot of cases. So I'm creating a little dictionary here. Let's just remember that syntax. So ag is just the name of my variable. Equals is the assignment operator. So I create a variable and I'm going to assign something to it. And on the right side, we have curly braces. Then we have a key, a colon, and a value. Now, for a dictionary, they can be anything. And I'm using strings on both sides. But I can't put anything here. These need to match up with functions that are part of the pandas library, right? So sum and mean, and we're going to look at a couple others. And there are probably a dozen functions altogether that you can pass in, and you can look at the documentation and play around with this. But so on the column, these keys need to match my column names. Total pop, I'm going to apply the sum function, and median income, I'm going to apply the mean function. So here I get the cities just for the columns I want from this list. I group them by state, then I call mean, right? And this is what we were doing before, and let's just comment that out, right? So here we get the mean of both of them, but if I want to use these aggregates, I call ag, and I pass in this dictionary as data, as an argument to the ag function. All right. So we're going to run this. We reset the index. We sort the values by state, I guess. We could sort it by total pop. Let's see. We'll sort it by total pop. And then we're going to get the largest states. The smallest states, and the median income, right? So this is the total population living in urban areas and the average median income for those cities, right? Okay. Now, let's just take a look at a more full example, right? And it's going to work the same way. But what we're going to do is, instead of grouping by state, we're going to look at the racial pluralities of cities. So this is something that we did in our last lab, and we're going to take a look at this same process again, right? So we get the city, the state, the population, the ethnic groups, the median income, poverty, number of people in poverty. Create a little function called getPlurality that takes in a row. We're going to use it in apply. And we call ID max to see which of these has the biggest value. We save that string and we return it. And here we create a new column called plurality, which is going to be one of these column names for each row, with whichever had the biggest number in it. All right. We calculate our poverty percent, right? We're using this vector. So we've got the new column on the left side, and I often like to use the dot notation here. If our names are unique and valid variables, we can use this. It's a little bit easier to read, a little bit easier to write sometimes. So here we're creating poverty percent as a real number between 0 and 1 by dividing the number of people living in poverty by the total number of people living in that city, right? And then we're going to do a for loop here. This is something we haven't really done yet. So let me explain it. For is a keyword. And this is similar to apply, where we're going to operate over a list of items. When we do apply, we do that function for every row in the data set, right? So here, I'm going to say for every column in this list of column names, so they're strings, I'm going to create a percent column. So my new column is going to be named like Asian underscore PCT, Black underscore PCT, Latino underscore PCT, White underscore PCT. I'm going to calculate a new column for that. Okay? And that's going to be the Asian percent, the Black percent, right? So the total number of Black people divided by the total number of people in that city gives us Black percent. All right. Created my fields, and then this is what our data looks like. We're sorting by white percent. So Dearborn, Michigan has the highest white percent in our data set, right? And this is the ungrouped data just with these new fields that we've calculated. Okay. Now, value counts. This is another aggregate function that we can use. And basically, we run it on a column, and it tells us, it looks at all of the unique values in that column, and then it counts them up. Value counts. Let's just take a look at our data with the plurality in it. Right? So we have the city, and then we see that Birmingham is maybe a majority Black, but definitely Blacks are the single largest ethnic group in the city. So Huntsville is white. Mobile is black, Montgomery black, and so on. Tuscaloosa is white. And we calculated this for every row in our data set, right? So we've got 340 rows, and they each have this value. Now, if we call value counts, so value counts being an aggregate function, it's going to look at the column plurality, find all of the unique values, and then count the number of times that each unique value appeared. So we get one in this aggregate result. We get one row for each unique value in the first column, and then we get the number of times that appeared in the second column. So in our data set of 340 cities, 212 of them are plural white, 87 plural Latino, 31 plural black, and then there are 10 cities where Asians are the largest single ethnic group, right? So we're going to add this as an ag function and mix it in with the means in the next section, right? So again, we create our dictionary, left side column names, right side the name of the function we want to call. And I'm just showing you how to do something where we don't want to write something twice. We already defined the columns we want in our data, right? They're all here as keys. So we're going to call the keys function on ag, and that's going to tell us which columns we want to get for our selection. We convert that to a list because it's not really a true list. It's a list-like object that gets returned when we get keys. But we want an actual list so that we can combine it with state. So here we're adding one list with a single item with the columns. And often we'll do this all in one line, right? So we create this first list we want to add to it. Then we get the keys, we convert it to a list, and we can do it all in one line, even though we did it in 3 lines here for clarity. All right. So pluralities is going to get just the columns we want from our data. We're going to group it by state and plurality. So we're using two columns to group by, and we apply these ag functions to it. All right. Now, because plurality is in there twice, I'm going to rename it to the number of cities, because our new plurality is actually holding the count of the number of cities in that group. We reset the index to flatten it, and then we can take a look at that data. All right. We call sample. Okay. So when I read this table, let's sort this first. So let's actually pluralities.sort by, and we'll do state. And we'll do head, right? Because, sorry, sort values. Okay. So we can see, if we take a look at it this way, Alaska only had one unique plurality. So for all the urban areas in Alaska, the urban areas are 55% white, they have 9% poverty rate, and so on. And there's only one city in this group. So there's only one city in Alaska. It's probably Anchorage. Obviously, it's Anchorage. And it's plurality white. Now for Alabama, we can see there are 5 cities altogether, and they've got 3 plural black cities and 2 plural white cities. So we can compare them if we want to. We could say that we can see that the white cities have a 5% lower rate of poverty than the plural black cities do, right? So this is the kind of thing we can do with this. Now California has, well, we knew that California had the largest number of large cities. And we could see there are 8 Asian plural cities, 40 Latinx cities, and 28 white cities. There are no black pluralities in California. And this is now our data grouped on 2 items, including the categories in this column plurality. All right. So continue working with this just to make this a little bit easier to read. I'm going to show a new thing. So every data frame has this style object, and we can call format on it. And format is another dictionary. Again, the left side are the keys are column names, and these are just format strings, like f-string format specifiers. So we pass in this format string, and it's going to apply that format to the value in the column, right? So for here, total pop, we're going to round it. I'm not even including it because we didn't put it in our data, but it's going to be have commas. And then for the percentages, we're going to actually use this percent format, right? So let's run this. Okay, and it's just easier to read. It's a nice way to format our columns. And the nice thing about using style is we're not actually changing any of the data in pluralities. We're just basically giving a template on top of it to format it. So previously, we're actually replacing the data that was numeric data with string data. This is, let's just keep working with the data and just present it in a different way. All right. So here, just another look at it. We're filtering, so we can get just the black plural cities, and we can see which states have the most plural black cities in them. So Georgia has the most plural black cities. Alabama, Louisiana, Florida, Virginia, Texas, North Carolina, Mississippi. All right, and then we get to Michigan and New Jersey. So really, we can see none of the West Coast cities are near the top of this list. So most of the concentrated black African American urban areas are in the southeast and in the older urbanized north. All right. Merging is when we take 2 data sets and we combine them into one data set. And the main thing we need to know is that they need to have a column that has the same value. So where a column in data set A has the same values that mean the rows represent the same thing in data set B, right? So here, we're loading in a new data set. And these are the state level demographics. So this is different than the city level demographics for states we're looking at. So now for Alabama, the total, but it has all the same columns, right? So the total population is the total pop. It's everyone living in Alabama, not just in urban areas. All right. So up here, I'm creating a new slice of our data, and it's going to be the cities grouped by state. So we're not working with the pluralities anymore, and I'm calling it city data. And then I'm loading the state data in here, and we're going to merge them into one thing. We know our cities already have a column called state, and we're going to use this key field to merge it, right? So the first thing, I'm just making sure they have exactly the same columns in each of them. So I'm selecting from state data only the columns that are in city data, right? And then I'm creating this new merge data set. So I call the merge on city. So city data dot merge, and I'm passing in the state data. And then I have a named argument on, and this is the name of the column. And that's going to match them up. And then because they have the same column names, I'm going to say I want the left ones to have suffixes of urban and the right ones to be state, right? So if we see the desserts, the results, I have Asian urban, poverty urban, and then I have them all the same Asian state. So for Alaska, we have 28,000 roughly Asian people living in cities greater than 100,000. And in the entire state, we have 46,500, right? So a little more than half of them are living in urban areas, and the other half are living in less urban areas or non-urban areas. Okay, so this is our new data set. We've got all these columns in it. And we're just going to take a look at this, all right? So I'm making a smaller data set to make it easier to look at. We're taking the state, the total population of the state, the urban population for that state, the black urban population, and the black population for the state, right? The total population for the state. And from this, we can calculate the percent black, urban, right? So the number of urban black residents divided by the total black residents in the state. And then we can invert that and get the non-urban blacks just by taking that number. Because in our data, they can't live both in an urban and non-urban area. Okay, so get a few columns, sort it, and then I'm going to rename them here, right? So what we can do, let me just, we'll just show this for now, just so you have a sense of where we stand, right? So here's our data. Total population in the state, the black population in the state, black percentage, urban, non-urban, right? But we're going to make this easier to read by doing a couple tricks. And when we present our work, like going forward, we're going to want to do this when we actually display something. So I'm renaming all the columns. So I have to provide one item for each column to rename them, and they have to be in the same order. So the first thing is I rename the columns, and I create the styles that I want for those columns, keys, and then the format string. I have some titles, and then I show the head and tail, right? And we're sorting it by black, non-urban percentage. Okay. So if we see in Mississippi, 82% of the black population lives in a large city, right? Where if we go down to Utah, 98% live in non-urban areas. So most of the black population lives outside of the urban areas. And we can see the same thing in Puerto Rico. But we also include the numbers, so we can see that they're only a small percentage of the overall population in these places. And so that accounts for how they can be skewed a little bit more. And that's it for today's view. In this notebook, we looked at grouping data. We looked at using aggregate functions and then merging data sets, right? And in the end, we looked at ways that we could group and merge to do and I guess, let me just add in styling data with the style attribute. Also along the way, we picked up some things about doing for loops and using dictionaries. All right. Enjoy working with this data and aggregating and merging, and I will see you soon.